Discard all solutions into the waste container provided. Obtain instructions for using your spectrophotometer. Obtain your unknown. Mark 7 dry test tubes with a series of identification numbers running from 1 to 7. Use a 5 ml pipette to make the additions of 0.15 moles of cobalt chloride hexahydrate and distilled water. For the first test tube, you're gonna need 5.0 mils of the 0.15 moles cobalt chloride hexahydrate. And 0 mils of distilled water, so no water needed.
So I'm just going to add all the cobalt chloride hexahydrate first before doing the water.
Alright, so for the second test tube, 4.0 mils of 0.15 moles of cobalt chloride hexahydrate for the second test tube. For the third test tube, 3.5 mils of 0.15 moles cobalt chloride hexahydrate. For the fourth test tube, we're going to be adding 3.0 of the 0.15 moles cobalt chloride hexahydrate. For the fifth test tube, we will be adding 2.5 mils of the 0.15 moles cobalt chloride hexahydrate. For the sixth test tube, we'll be adding a solution of 2.0 of the 0.15 moles cobalt chloride hexahydrate. for the seventh test tube, we'll be adding 1.0 mils of the 0.5 moles cobalt chloride hexahydrate solution. And now we're going to go ahead and add the DI water in each test tube. So for the first test tube, there is no water, and the second test tube has 1.0 mil of DI water. For the third test tube has a 1.5 mil for DI water. For the fourth test tube has a 2.0 mil of DI water. And for the fifth test tube have a 2.5 mil for the DI water. And then for the sixth test tube has a 3.0 mil of DI water. And for the seventh test tube has a 4.0 DI water. 1.0 mil of DI water. Thoroughly mix the contents of each test tube by gently shaking the test tube from side to side. Obtain the absorption spectrum of aqueous cobalt chloride by using the contents of the first test tube. First test tube and measuring the absorbance at the intervals of 25 nanometers between 400 and 600 nanometers. Okay. So these are all the calculated numbers for each nanometer, and as you can see, it started going down after 500 nanometers. So since 500 nanometers is the highest one, we're going to use that nanometer to calculate the absorbance of the rest of the test chips. So we had to redo test tube 3 because the cuvette we used for it had a writing under it, and it gave, because of that, it gave it a different absorbance level, but now we tried it again with a different test tube. And
It could also be because of the scratches on the cuvette.
yes, and that too. So we had to redo it, and we did it with a clean cuvette, and the score or the amount came out differently. So instead of 1.131, it was actually 0.525. So I'm gonna go ahead and correct that. So now that is the correct one. So this is the one that we corrected, and then you see how it goes down. It regresses as we go down. So that's it. So now you can begin to work on your unknown. Use the following guidelines in establishing the molar concentration of cobalt chloride in the solution. A few milliliters of this solution must be diluted until the absorbance lies within the range of that you found in step 6. All right, so we grabbed 2 mils of the unknown solution, and then we did not add any DI water to it, and the absorbance was 3.0. So now we have 4 mils of the unknown, and we added 1 mil of the diluted water. So now we're about to find out the absorbance. So the absorbance is 1.28. 1.282. So now we have 4 mils of unknown. We mixed it together with 1.5 mils of diluted water. So now we're about to calculate the absorbance. And the absorbance is 1.60. So 1.160. So 1.160. So we have 4 mil of this unknown, and then we have 2.5 mil of diluted water. And let's see what the absorbance would be. And the absorbance is 0.957. 0.957. So we have 4 mil of the onion solution and then 4 mil of DI water, and we're gonna calculate the absorbance. So now that is what we have been trying to get. So that's gonna be 0.758. So this is perfect. And you can see it ranges in between these numbers, and especially it got close to this one. So that's what we have been trying to do.